Hello everyone, welcome back to our channel. Today we are going to explore one of the most fascinating and mysterious topics in the astrophysics, black holes. Specifically, we'll understand what the singularity and event horizons of the black holes are and why they are called as the age of the space-time. Let's dive into the mystery of the black holes. So let's get started. First, let's start with the basics. What exactly is the black hole? You might remember from the school that gravity is the force that pulls things toward the earth. Now imagine a region in a space where gravity is so strong that not even a light can escape it. That's what makes the black hole so special. A black hole is formed when massive star collapses under its own gravity at the end of its life. In simple terms, black hole is a region in a space where gravity is so intense that anything that gets too close get pulled in, and once inside nothing can escape it, not even a light. Now let's see how black holes are formed. When a massive star, much bigger than our sun, reaches the end of its life, it runs out of the fuel. The star starts collapsing under its own gravity. As it compresses, gravity gets stronger and stronger, and eventually the star explodes in a supernova. After the explosion, the remaining core of the star is so dense and compact that it turns into the black hole. Even though a black hole has enormous mass, it occupies almost no volume at all. This is what gives it so much powerful gravity. Now let's talk about the event horizon. The event horizon is the invisible boundary around the black hole. Once something crosses its boundary, it can no longer escape the black hole's gravitational pull. This is why we call it a point of no return. The size of the event horizon depends on the mass of the black hole. The larger the black hole, the bigger its event horizon. For a small black hole, the supermassive black hole, the event horizon would be vastly different in size. At the very center of black hole, we have a singularity. The singularity is a point where all the mass of the black hole is compressed into the infinitely small space. Can you imagine the kind of gravity and density that would have existed at such point? At a singularity, gravity becomes so intense that the space and time as we know them break down. The laws of physics that govern our universe no longer applies. This is where the space-time ends and everything we know about the universe falls apart. Let's dive a bit deeper into the concept of space-time. According to the Einstein's theory of general relativity, space and time are not separate entities but they are interconnected and form a fabric called space-time. When a massive object like planets or stars sits in the space-time, it distorts the fabric, much like placing a heavy ball on a trampoline. In the case of black hole, the distortion becomes so extreme that it bends the space-time in such a way that at the singularity, space-time breaks down completely. This is why singularity is often described as a point of space-time itself no longer exists. This bending of space-time is what causes the intense gravitational pull of a black hole. And this concept of space-time being curved what makes the black hole so fascinating and also difficult to understand. Did you know there are different types of black holes? They mainly come in three categories: stellar black holes, supermassive black holes, and intermediate black holes. Stellar black holes form when massive star collapses under its own gravity. These black holes typically have a mass of 5 to 50 times that of our sun. Supermassive black holes are found at the center of the most galaxies. They can have masses that are billions of times greater than our sun, like the one at the center of the Milky Way galaxy called Sagittarius A. Intermediate black holes are smaller than the supermassive but larger than the stellar black holes. These are harder to detect, but scientists believe they exist. One of the most interesting questions about the black hole is, can we ever see inside a black hole? The short answer is no, because of the event horizon. Once something crosses this boundary, it can never escape. This means that we can never see inside the black hole. Even though we can't see inside a black hole, scientists have discovered a lot about them through indirect methods. By studying how stars and gas behave around the black holes, we have learned quite a bit about their properties. Black holes are not just mysterious objects, they also play an important role in the universe. Scientists believe that the black holes may actually be involved in formation of galaxies. Most galaxies, including our Milky Way, have supermassive black hole at the center, which helps them shape a galaxy. In fact, some scientists think that galaxies and their supermassive black holes evolved together. This suggests that the black holes might be essential to the formation and evolution of galaxies. Now, Let's talk about some of more speculative theories related to the black holes. For instance, there is the idea of wormholes. Some theories suggest that the event horizon of the black hole might be gateway to another part of universe or even the another universe. Another idea is the black holes could be the potential to the parallel universes. But these are just theories at the moment and there is no proof of support them yet. So, to summarize everything we have learned today, a black hole is a region of a space where gravity is so strong that nothing can escape. The event horizon is the boundary beyond which nothing can return. And at the center of the black hole, we find the singularity, a point where gravity and space-time becomes infinite. Black holes are truly one of the most fascinating and puzzling objects in the universe. As we continue to explore them, we might uncover even more amazing facts about these mysterious cosmic giants. If you enjoyed this video today, make sure to like, share, subscribe, and stay tuned for the amazing videos about the space and the universe.